liberal than most people assume. I actually do believe in global warming. I'll probably go to hell for it, but whatever. All right, there you go. Thank you. Here we go. My good friends. Mr. Durant went over titrations the other day. They're actually really, they're like awesome. How they work and how simple like science they are and how simple math they are. As a review, we have some sort of unknown acid or base. We know how much there is of it. That is the thing I can measure with a graduated cylinder. Okay, I'm a little worried about Gabe back there. He's eating cake on top of a box of donuts. It's okay. You only weigh 108 pounds, so you keep going. All right. Now, so you have an unknown concentration, but a known volume of whatever it is. You want to figure out what it is, and this works with acids and bases. It works with like precipitate reactions too, a little bit different way, but we're not going to worry about that. It's actually a really cool one. I can't not talk about it. It's really cool. You can do a titration based on conductivity, and you can use a titration to turn a light bulb off. Like, it's really cool. Yeah, it's really cool. I'll try and look it up. I have done that demo. It's really hard to get perfect, but it's kind of cool. Anyway, it has a few applications. So you're unknown, you add an indicator. An indicator is something that changes color in the presence of H plus or OH minus. All right, here you go. So typically we use like universal indicator. We can use a bunch of different ones. It doesn't really matter, but you put the indicator in, and this one, once you put the indicator in, it's still blue or whatever. Tell your partner if you have any guess, if you've read it all, is this substance a base or an acid? It's a base. Ow. Who put that there? Bases turn dark colors, or I should say indicators turn dark colors in bases. And typically, it should be darker blue, but it's fine. Whoever drew this wasn't me. All right, enjoy the rest of your sugar. Oh, yeah. Okay, the rest of you are out of luck.
Wait, so it wasn't acid?
No. I'm asking what this is. This is currently a base because it's a darker color. It could be either one. This can be a base and this can be an acid, or this can be an acid and that can be a base. It doesn't matter. No, because the moles of acid equal the moles of base, or the moles of base will equal the moles of acid. We can do it either direction. It doesn't matter. Oh, it does. Okay. Good point. It does say it's an acid. I don't know why they didn't color it then, because this is not how it would work. It doesn't really matter ultimately, but good eye. Okay, now we want to figure out what it is. So if this is an acid, apparently we're adding what here? Base. All right, so we're going to add base until this turns neutral. If its initial reading, let's just say it was like, I don't know, 40. And then down here, let's say it was 8. Sorry, my bad. Then what does the change equal to? 32 milliliters. So we'd say it took 32 milliliters to neutralize whatever this was. So far with me? So we measure how much we add. Now we would know the concentration of this as well. The reason we know the concentration of this is because we went in the stock room and we found one. And let's say it's 1 molar. You okay with that? So you have 32 milliliters of 1 molar. And apparently it has to be a base. It took 32 milliliters of 1 molar base to neutralize, I don't know, what's your favorite number under 100? 65, I heard. All right, so we're going to say there was 65 milliliters of acid. Okay. Now, all this is made up. You're like, where's he getting these numbers? I pulled them from my brain, and then I just forgot her name. Sleeman. No, that's the other one. I'm in a lot of trouble. Moving on. Musselman. Now I got it right. Okay, so when you have two of these values connected by of, I want you to multiply them. Does that sound familiar, maybe? And then what do you do with the other number? We don't have to convert it to liters, actually. You divide. Whoever said that, they sound like a base. Good job. All right, so you take 32 times 1 and you divide it by 65. And you get around, I don't know, I'm going to say 0.5-ish. Okay, the titration takes advantage of this fact. Look right here. This amount of base with this concentration has to equal this amount of acid with whatever its concentration is. So the math is A times B has to equal C times D, which is multiplying the pair and dividing by the other thing you're given. Multiply the ofs, divide by the other value. Okay, let's look right here. I did not type this, all you Comic Sans haters. I cut it from the internet, okay? So here we go. If it takes 54 milliliters of 0.1 molar NaOH to neutralize 125 milliliters of HCl, what is the concentration of the HCl? Will you calculate that quickly? Oh, I didn't realize. I've cut this from somewhere in Europe. This worksheet is somewhere not in America. You'll figure out why.
Oh, that's disgusting.
What?
Why would it spell it like that?
Because they weird.
That's one way of putting it.
Don't worry about it. Keep going. Sulfuric.
Oh,
Don't worry about it. We'll do fine. Who has an answer to number 1? Anyone? Okay. Well, I'll keep waiting. Of titrations? Yeah. It's from last year. I don't know. I don't think she recorded while you were at volleyball, but you're going to understand it in the next 5 minutes, so don't stress about it. Okay, here we go. Thank you, my wonderful friends. I'm only sucking up because my birthday's in a couple of days. Back by Monday, I won't like any of you. Okay, except for Tim.
what?
Are there two numbers that are close to each other and connected by the word of? Yes, turn the of to a multiply sign. 54 times 0.1 is 5.4. That's your answer to that part, right? And then what do? You divide it by the other number that wasn't next to it. And you get a pretty small number, 0.0. Ha, ha. Boom. 4, 3, 2, 1. Okay, I'll shut up. Hey, who got 0.043? Raise your hands. Tell your partner how you did that. All right, come back in 5, 4, 3, 2, 1. You guys are great. So you found the two numbers, you multiplied them and divide by the one that didn't belong. What's the connector? Of. Here we go. Do you see an of in question number 2? Yeah, what are you going to do? And then what are you going to do? Divide it. Okay. Yes. For number 3, there's something different. You can do that, or your answer by 2. Either one works because it's the same math-wise. Okay, number 2, did we get something like 0.004? Okay. All right. Oh, spoiler alert. All right. If it takes 50 milliliters of that to completely neutralize 125 milliliters of sulfuric acid, whatever, what is the concentration of the acid? Will you try that one real quick? Then we'll talk about a small red flag. I don't believe you. I believe that you are being sarcastic and you dislike them. I'm really embarrassed. All right. Right here, Seth. Or there's one back there too. Okay, let's get some answers. Show me what your calculator says. 0.2. That is not the right answer.
I give up on life.
I'll call your counselors. Okay, Payne, you want to explain?
She got it first, actually. So
Okay.
There's actually 2 H's in the sulfuric acid. So yeah, by 0.2 by 2 to get 0.1.
Okay. For every one H2SO4, there's 2 H's. So divide your answer in half. So divide your answer by the number of H's in the acid. Okay. So just be real careful with that. Just once in a while, they'll do you kind of mean like that. They could do H3PO4, and then you would divide it by 3. No, you won't. Not yet. All right. So here's a couple more. Practice. When you feel that you can do these, grab an iPad and you're going to take a non-graded, like it'll be graded, but it's not on your grade. Grab the iPad and do a little quiz for me when you feel comfortable. I will show the answers so you know if you did it right. So when you feel good about it, take this quiz. It's at the very bottom of Unit 4. It's called Titration Practice Quiz or something like that. Oh, no. Interesting. Why? Yes, like 2 days ago. What? Different class. Why? 1 second. Yep. Must be that time of the month where they have to be reset. Hey, is anyone struggling with number 9? Because you realize that magnesium hydroxide has 2 OHs. Yep, the answer is 63, but you must divide by 2 because there's 2 OHs.
So you're telling me if we can find out one, we have a 50% chance on the age?
Yeah. Girl. Okay, here we go. Based on everything we've ever learned about solubility charts, my circles mean no precipitate was formed in the chart. I want you to take a minute and think right now, if you were forced at absolute pure peer pressure to tell me what this acid was, don't say it out loud if you already know. I want you to tell your partner, I think C is probably this acid because you bet your acid it doesn't do anything. Talk. You're amazing. Did you know that too? She's amazing. It's an awesome question. The problem. All right. They're just ones in my back room. But you're welcome to go look at. No, you're not. No, you're not. Most acids we use in class are strong acids. Okay. Can I pick on you? What was your guess? She said nitric acid in about 0.015 seconds. Why? She's right. Like when in doubt, copy Brown. But how come? NO3. Do we care about the H in any of this? No, like it's an acid, but really it's an anion delivering agent. It's just bringing NO3 to the party, and then the NO3 is going to leave it anyway as soon as it's in solution anyway, right? Okay. These are a little bit trickier, but what you need to think about tomorrow, because for the kids that get all of it, this is such an easy question. For the kids that get none of it, there's no chance. You're like IDK, like for real. Like you don't know. For the middle ones, it's a good time to think. You will have the solubility chart. Where do I have that paper? Right here, probably. Oh, you will have this piece of paper. Everyone gets one of these with your test. It has the solubility rules. And right there, hey, HNO3. It could also have been what other acid? Anyone have that memorized? Acetic acid. Okay, and it won't be. I'll tell you right now, one of A, B, and C is nitric acid. It could have been that because that also doesn't form, but it's a weaker acid, so it's a little bit trickier. Okay, I'm not going to give you more than that. I think you can get it based on the solubility rules and what would be made from what. Okay, how much longer do I have in here? 1 o'clock, 13 minutes, right? Let me double check what else we haven't done. All right. I will change these so they won't be the exact questions. But number 5 will be just like this. It will say, which of the following reactions will not happen as written and why? All right. So all of these, they have solid iron. That's an element, right? Acid is dripped on a piece of barium. That's an element. Gold is placed in whatever. That's an element. All 3 of them have a lone element. So all 3 of these are testing what concept? Redox. You guys are amazing today. All right. So this is assessing this chart. Do you remember that? You wrote something about this chart in your notes somewhere. You wrote, in order for reaction to happen, yada, 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 yada. Find that. Find that, and I'll bring the chart up. Come on. Hey, while I'm waiting, will you politely tell your partner what the charge of silver is? How many fingers? Okay, it's 1. Remember, she's mad because you gave her silver. 1. Oh, don't do that. Are you kidding me? No, for some stupid reason, Tom Davidson created 3 slideshows in the last 2 days. Thank you. Like, it's the struggle is real. All right, because I'm trying to bring up the sheet or the whatever. So don't make me do that. The activity series. I'm trying to find the slide with the activity series on it. Here we go. Okay, not real easy to see. Should I swap the screens? That's good enough. Okay, answer those then. See if you can answer them. Tell me if they'll happen and tell me why. If you're watching this review at home tonight on the internet, you'll have to find this right here, because this won't be on the recording. Yeah, this sheet is what you'll be given. The activity series is on the bottom. Solubility rules on the top. And on the AP test, you would have something like this. You have that in your notes, right? That red part? Okay. Just double checking. You have it? Okay. All right, no. Okay, here we go. That video ran the whole time. I'm sorry if you're bored. Oh no. Okay, please back with me in 4, 3, 2. You're awesome. Solid iron is added to a solution of lithium chloride. Does a reaction happen? No, how come? Lithium cannot oxidize iron. Would the other one work if it was the other way around?
Yes.
Absolutely. Acid is put on a piece of barium. Yes, because hydrogen can oxidize barium. Gold is placed. You don't even need to read anything else. No reaction, right? Gold is unoxidizable. Like even if it was platinum, you'd still have gold. Gold, solid gold will not react. If it's in solution, it will always come out of solution, right? Thumbs up. Just practice and whoops, I missed. If I just broke the pen, you are dead. Okay, it's good. You're still alive. I don't do it with this very often. I'm pretty good with board markers. All right, my friends, let me look at the test. The girls in the back asked me, like, what's the best way? How do I study? Well, the overwhelming majority of points comes from one of these problems. Nope, 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 nope. Different review. Hold on. Uh-oh. All right. Like we've done this before. We've done 10 or more of them. The biggest chunk is one of these. A solution stoichiometry problem. Like, oh, I've never seen those. It's never too late to drop the class. All right, that's where the majority of points will come from. Okay, hold on. No, you should stick. There's like 3 people that should drop, and you're not one of them. No. Okay. All right. I want to talk about this equation. Barium hydroxide is added with sulfuric acid. All right. Pop it.
I played basketball on Saturday.
That was dumb. Okay. Can you tell me, is this a red flag? No. You guys are so easy to manipulate. I love you. No, we have an acid. We have an acid, which is a good start. But is that a red flag? No. Sulfite. But that would be an acid plus sulfite. This is in the acid already. So this is just a what type of reaction? Quiet. One on the back. Neutralization. Who said double replacement? That's right as well. It's a neutralization reaction. All right. So what would I have over here? Don't at me that I didn't even leave any remotely close room here. Oh no. Oh well. What are my two products? Water. What state is it in? Plus, what's left? You would check the solubility rules. Off the top of your head, is it aqueous? The bottom of your head is no, and that's right. Okay, tell me something here. Before this reaction happened, is that a strong acid? Yeah. Hydroxide, oh no. I know its family 1s are strong and heavy family 2s. Is barium heavy? Yeah, it's at the bottom, right? So this is aqueous. None of them on the other side are, which means what about electrolytic properties? There ain't no spectator ions. There's no ions. Think about this tomorrow. There are no ions. It's not a trick question, but you got to realize what no ions means. No electricity can pass through it. Remember a minute ago, not a minute ago, like an hour ago, like, hey, titration is actually really cool and where you can turn a light bulb off. Well, this is how you do it. You have some barium hydroxide or sulfuric acid. You add the other ones, and at first it's really bright. You have that little probe. Remember my little probe thing I showed you? Super bright, and then it gets dim, 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 dim off, and then it goes back on if you go past. Hey, please find ways to study. I love you. It's a hard test. It wasn't supposed to make you feel better. It's supposed to make you feel great.